So we'll move on to the problems on pyramids and the axis is inclined to both planes. In that case, you can have actually the first type of problems, the simple problems where you'll say that the pyramid is resting on one of its base edges on HP. The axis is inclined with HP and the edge on which it is resting on HP is inclined at some degrees to VP in that way. So the axis inclination will be given and the edge on which it is resting on HP will be given with the inclination with VP. So in that case you can have a problem something like this. In any pyramid, same condition where they say the pyramid of base edges of some length and the height of some length is resting on one of its base edges on HP such that the axis is inclined at say some 45 degrees to HP and the edge on which it is resting is inclined at 30 degrees to VP. So in that case we'll see how to solve that problem. So you can find actually a problem in the prisms, the exercise where they say these conditions. The axis is inclined to HP with some degrees, say 45 degrees. The second case says when it is resting on one of its base edges on HP. So the condition will be resting on base edge. So this is for the case where resting on base edge, one of its base edges. So base edge, one of its base edges. So resting on base edge. Axis inclined to HP, and they say the edge which is resting on HP, the edge which is resting on HP is inclined to VP by some degrees, say 30 degrees. And that way we want to find the problem. So whenever I have any prism, whether it's triangular, square, pyramid, not prism, sorry, it's pyramid, any pyramid, a triangular pyramid, square pyramid, rectangular pyramid, pentagonal pyramid or hexagonal pyramid. So the same procedure. In that case they will say that the pyramid is resting on one of its base edges on HP. So in that case you go for constructing the base edge of the pyramid perpendicular to XY line. You construct that polygon. It's a triangular pyramid, you go for constructing a triangle. If it's a square pyramid, construct a square. If it's a rectangular pyramid, construct a rectangle. If it's a pentagonal pyramid, construct a pentagon. If it is a hexagonal pyramid, construct hexagon. So I'll go with the triangular pyramid. So if this is AB, then this is C, then it will be a triangular pyramid. So this is C. Then locate the center, bisecting any two sides, O and O1. So then you can see this inclined edges of that. Okay. So go for projecting this. Get the base. Project the axis. So in the problem it will be given the axis length. So take that axis height of the pyramid, take that length, so then that will be O. So join to that O, which is called as apex. Then this is A dash, B dash, C dash, and this is O dash. It says any pyramid, the same procedure. It says is resting on one of its base edges on HP. You'll find that sentence in the problem. Then it says axis is inclined at 45 degrees to HP. So I told you in the previous case that if the axis is inclined at 45 degrees, you can go for inclining the base at 45, 90 minus that axis inclination. So incline the base at 45. Then you redraw that. Then the axle will also incline by 45, 90 minus that 45. Otherwise, in the problem itself, they can mention that the base is inclined at 45 degrees. So on the same problem, it says is resting on one of its base edges. A pyramid is resting on one of its base edges on HP such that the base is inclined at 45 degrees to HP. And they say the edge which is resting on HP is inclined at 30 degrees to VP. So they can give you the axis inclination or the base inclination, the same procedure. So then it will be this A dash B dash. And also I told you the previous problem, so the base inclination or the axis inclination can be given, or even they may say that the triangular surface containing that longer edge, that is A1 B1 if that is the longer edge resting on HP. So the triangular face is inclined with some angle. In that way also they can give you. Then you can go for drawing that line. Then you construct this triangle taking this length, draw an arc. Then taking this length, you can draw an arc and you can complete this view. So they can give you 3 different conditions. The sentence can be changed in this way: axis inclination, axis is inclined, or base is inclined, or triangular surface containing that edge which is resting on HP is inclined. So in that case, the same view. So check out, you go for drawing in that position. Get the view. This is A, B, C, this is O1, this is O. Then because apex is near to the observer, you cannot see the base completely. So this becomes a dotted line. So AB cannot see. Then it says edge which is resting on HP is inclined at 30 degrees to VP. Now the edge which is resting on HP is nothing but AB. So that is at 90 degrees to vertical plane. That should be made inclined at 30 degrees. In that case, even they can mention one more condition saying that the edge on which is resting is inclined at 30 degrees to VP and the base is nearer to the observer, or base is nearer to VP, depending upon that. So this is the condition what I have done now. So base is inclined at 30 degrees. So if you are looking at the front view, this will be the case, resting on this edge. So base is inclined and at 45 degrees, axis will be also inclined at 45 degrees. So now this base edge is perpendicular to VP. That should be inclined at 45 degrees. Then you have to turn in this way. So then the base will be nearer to the observer, or you can turn in the other way. So to incline that edge at 45 degrees to the vertical plane. So in that case, base will be nearer to VP. If they don't mention, you can draw in any position. Then I'll take the base towards the observer. I will just go for drawing that. So I'll redraw this 1, 2, 3, 4. I'll inscribe this pyramid in a rectangle. Then I'll go for drawing that rectangle. Take that length. This is 1, this is 2. Draw this 2 to 3. I'll take and I'll mark that. So then I'll get 3, 4, 1, 2, 3, 4. That O is here. Then at this length, I'm going to have that AB. I'll just draw a line. I'll get that A and B. So this is C. So we'll redraw the sketch. Same view should be redrawn here. Then I'll project all the points. Okay, I'll project all the points. Draw locus from all the points. Then, okay, this dotted line of it to redraw. The same view should be redrawn. Then mark that O1. This is O, right? Same view. Then I'll project even that O1. So this is O1 and this is O. So then A and A, this is A, B and B, this is B, C and C. So this is C, O and O, so this is O, O1 and O1, O1 and O1, so this is C, right? So then the base is nearer to me, so in this case, because base is nearer to the observer, I can go for completing the base edges with a thick continuous line. So then the axis will be somewhere here. Say this is the one. So the base is near to the observer, complete the base, then go for the outermost edges. So A, B, C are not joined. So this is A dash, B dash and C dash. So OA is not joined. Now that will be a dotted line because this is the visible surface and this is the base where you cannot have any edge on the base. So that is nothing but the invisible edge that we can make out. So axis line first starts from here. Go for drawing the axis with a medium thickness and show that the axis with the chain line, big dash or small dash. This will be the solution. A very simple problem that can be given in the exam. Nothing to worry about the beta angle, no beta nothing. If the same problem is given, say with one of its corners resting on HP, we'll see how we can draw that. So in that case, what may be the condition that will be given in the problem? If it is resting on one of its similar problem, okay. So in that case, they can give you saying that any pyramid, I'll go for a pentagonal pyramid. A pentagonal pyramid having resting. So in that case, I'll say a pentagonal pyramid of 30 mm base edges is resting on one of its base corners on HP such that the axis is inclined to HP or base, what I in the previous problem, the same way, base is inclined to HP or they may say, in this case, a longer edge containing that edge is inclined to HP. So for all the conditions, it will be same. So this is the axis line. Just go for drawing. So I'll just go for dictating the problem and see. I'll just create a problem. Dashes. O dash. 1 dash. A triangular pyramid resting on one of its base corners and HP such that the axis is inclined at 30 degrees to HP, or they can give you the base inclined at 90 minus 30 degrees of the axis, so 60 degrees in that way you can say for the same problem, 60 degrees to HP such that so the axis is inclined at resting on the corner and the axis is inclined at 30 degrees to HP. Then he says for the similar problem that in the previous case it was said that the edge is resting on HP and the axis is inclined to HP. Then he says the edge which is resting on HP is inclined at 30 degrees to VP. So in this case I'll say now for the same problem there will not be any edge, so corner, I'll say the edge opposite to this corner. The edge opposite to this corner is nothing but this. So if this is the corner, the edge opposite to that corner is this. So and again when it is moving up, when we are giving the axis inclination, this edge remains parallel and it will be in the true length even in the second view. When they say the edge opposite to this corner, this is the edge opposite to this corner is inclined, because this is in the true length, I can go for giving the inclination. When it is resting on one of its base edges of HP, the problem was that axis is inclined at some say 45 degrees to HP, and the edge on which it is resting is inclined at 30 degrees to BP. Whereas here I can say the same problem, saying that is resting on one of its corners of its base on HP. The axis is inclined at say some 45 degrees to HP. Then the edge opposite to this corner is inclined at 30 degrees to BP, and the base is near to the observer or nearer to BP. Any condition they can give you. So I'll take nearer to the observer, draw its projections. In that case, what we'll do is, so we'll go for A says is the axis is inclined at 45 degrees. I'll go for inclining the base at 45 degrees. 90 minus that axis inclination 45 and 45. I'll take this length, first length, second length, transfer, and the third length will be the total length of it. Okay, so then this is the axis line, and this is A and E dashes. So this is B, this is the corner C, then D dash, all these will be dashes, and this is O1 dash. So anyway, this will be perpendicular because this is the axis line, perpendicular. First go for drawing that. Height will be given, so same height will transfer here. I'm redrawing this sketch anyway. Complete that. So the apex is O. Same view should be redrawn. Okay. So this is the condition where it says it's resting on one of the corner, that is C, on HP, such that the base is inclined at, or axis is inclined at 45 degrees. So I think so axis is given as 45 degrees, then when the base will incline at 90 minus that 45, so 45 degrees. So you can go for giving anything base in the problem. You can find base is inclined and axis inclined, right? Or even they can give you that the inclined edge, that's the longer edge, which is called as inclined edge in case of the pyramid, says that is inclined with some angle. Even in that case, you can go for drawing that. In some cases, they're going to give you that. So when say it is resting on its base on HP, so all these will be inclined with HP. Then they can say this edge containing that corner on which it rests is perpendicular to HP. See, if it is perpendicular to HP, so the solid will incline with the base and the axis. Instead of giving axis inclination or base inclination, they can refer to this inclined edge, or that longer edge perpendicular to HP, or any other inclination. Even then you'll see that the axis goes on changing, right? Anything can be given. So that is your first inclination. So it can be vertical or any inclination. In that case, you'll see that because it's already inclined when it's resting on base. That's why they call it as inclined edges. All the longer edges are inclined. They call it as inclined edges with HP, or with the ground, with the base. So in that case, when you turn, it can see, you can make it vertical, perpendicular to HP. In that case, the axis will incline. Even the base will incline. Okay. So instead of giving the inclination, they can give you in that way also. Or even this can be inclined in some other inclination. Instead of perpendicular 90 degrees, they can give you any other inclination. Even then you can go for drawing that. So the same condition. So go for projecting all the points. Get your view. So D, C, O1, C lying in the same line. This is B. So go for marking all the edges. So A and A, B and B, C and C, D and D. So A, B, C, D. And then this is A, this is O1, and this is O. So now when you look from the top, so the apex is near to the observer, so you cannot see the base completely. In that case, you go for completing all the edges with all boundary edges with a thick continuous line. Then I told you, so if this is the outermost edge and if the other end where you can see, so what these two will be the visible edges, you can see that's the topmost edges, you can see that edge. Then the edges, now all these area become surfaces, so there should not be any thick line on the surface because there will not be any visible edge on the surface. So this becomes invisible edge on the other side. So then these are the invisible edges. So DC, BC and CO. The axis line you represent only till you can represent, then it it is overlapping with the edge, so need not show that. Okay. So then in the previous problem it was resting on the edge on HP. That edge was said that it is inclined to VP. Now here the edge opposite to that corner C is nothing but this AE. So AE, the same length is projected, so it's in the true length. In that case I can go for incline that edge with the given inclination, say any inclination. So if it is inclined at 30 degrees, I will go for drawing at 30 degrees. Or I can inscribe this in a rectangle 2, 3, 4. So I can go for drawing that rectangle inclined at 30 degrees. So that way I can just draw a line inclined at 30 degrees anywhere here. So 30 degrees. This is inclined at 30 degrees. So go for 3 to 4. So extend that and get that 1 and 2. So same length I can take here. Okay. This is 1, 2, 3, 4. Then at exactly 1 to O, I can just transfer, get that O. So AE, 4 to E, same as 3 to D, I can get that D and E. So this is, A and E, right? Okay, A and E, this pyramid. Then 3 to B is also equal to 4 to D. Then 3 to B, 4 to D, I can get that. This is D and, this is B and AB, right? Okay, this is D. Then on this axis line, okay, so we're going to have O C1. So this is C1 and this is O. I can mark that point also. So this is O1, right? The same view I'm going to redraw now. Same view, but it's looking different. But you have to draw the same view. Go for drawing. When you take the scale correctly, get a similar view. This is a rough sketch anyway. So 3 invisible edges, so 3 invisible axis line. So this is the condition where I was satisfied. It says it's resting on one of its base corners in HP such that the axis is inclined at 45 degrees to HP. Then he says the edge opposite to this corner C. So that is the edge opposite to the corner which is resting on HP is inclined at 30 degrees. It was perpendicular, I made it 30 degrees now. So in this position, we'll see, because since here the base is near to the observer, so when you project, we'll check out whether if this is C is the outermost, you just go for projecting all that. Draw the locus. Go for locating all the points A and A. This is A dash. B and B, B dash. C and C. So this is C dash. D and D. So this is D dash. E and E. So this is E dash. So O and this is O1. And this is O1. Say let it be O1. And this is O1O. So since the base is nearer to me compared to the apex, so we'll go for completing all the base edges. So AB, BC, CD. So all this. So then we'll go for outermost edges. So if this is the outermost, let it be, or if this is the outermost. Okay, if you can see this end, at the other end, this is the outermost corner of the edge, and this is the other end of this AO that is visible. Now this becomes, all this becomes surfaces. Then this DO will become a dotted line, because you cannot have any dot line. Again, CO will be also a dotted line, invisible edges. So O, if you can show the O, show that O. So now this will be the solution for this project. A very simple problem that you can expect in the exam. Very simple problem. I'll stop here. I'll just go for the next class. I'll go for some other conditions where you can we'll have a different types of problems even in this case. The conditions where you have to take beta. In these cases, in these two problems, you need not take beta because the edge which is resting on HP in the previous case is inclined, which was in the true length. I give for the true length, we are given the true inclination. Even here, this AE is the true length that it just moves up when you bend. So that will be the true shape. Just incline that to give the inclination to VP, and that's the solution.